Hi everyone, welcome to this lecture. So in this lecture, we will learn about the stochastic gradient descent, which is the variant of a gradient descent. So basically, before starting the stochastic gradient descent, we must know about the three basic definitions or three concepts which are used in deep learning. They are epoch, batch, and iteration. So what is epoch, what is batch or batch size, and what is iteration? So let's start with epoch. So epoch is one complete pass of training data through the training model. If we set epoch equals to 10, it means we pass the whole training sample 10 times through the training model. Now, suppose we have a data set which has 1,000 training samples. So when we pass all the 1,000 training samples once through the training model, it completes one epoch. Then in the second epoch, we will pass again all those 1,000 training sample to the machine learning model. So if we set epoch 10, it means we are passing all the 1,000 training samples 10 times to the machine during the training. So this is the concept of an epoch. But what happens in deep learning? Usually in deep learning, data is very large and we have large number of training sample. Suppose we have 20,000 or 30,000 training sample. So it is not a good idea to pass all the sample at once. Therefore, in order to avoid this situation, we use batches to pass through the machine. Batch means select a small portion of the epoch. That is, batch size is the number of training sample we pass at a particular time for training the model. So suppose I have 1,000 training sample, but I pass 32 sample at a time. I first pass the 32 sample to the machine, then I get the error, I update the weights, then I pass the next 32. So every time the batch is passed, we update the weights and bias, and then we pass the second batch. So this is called batch training. So we usually use batch training in deep learning because the data sets are very large and it is not good idea to pass whole epoch at once to the machine. Now, associated with batch and epoch, there is a concept of iteration. So iteration are the number of batches we need to complete one epoch. So the concept is very easy and very simple. Suppose we have 1,000 training sample and we choose a batch size of 100. It means the number of times we need to pass batches to complete one epoch, which is called iteration, is 10 here. So in order to calculate the iteration, we have a very simple equation: samples in epoch, batch size. So here, if I have 1,000 samples and my batch size is 100, so I need 10 iterations to complete the epoch. That is, if the training samples are 1,000 and batch size is 100, so it means I need to pass 10 batches in order to complete 100 training sample. It means I need 10 iteration to complete the epoch. So this is the concept, or this is the definition of the iteration. So we complete the concept of epoch, batch, and iteration, which are three important but simple concepts in deep learning. Let's start the stochastic gradient descent. So in stochastic gradient descent, we use only one sample at a time. So the gradient descent becomes stochastic when we select one sample in each iteration and update the weight. Now there is a disadvantage associated with. The thing is, this is good idea to pass one sample in each iteration if all the data samples are similar. But it is usually not the case in the real world data, because the real world data is very versatile and the samples are very different from each other. So this is a disadvantage if we pass one sample at a time. The word stochastic means random. The word stochastic comes with gradient descent due to random selection of one sample. When we take one sample at a time to train the machine learning, it doesn't mean that it should be in order. That is, we first select the first sample, then second sample, then third sample, then fourth sample. No, we can select any sample at random. Due to the randomized selection during a gradient descent, we use the word stochastic. So stochastic means a random selection of a sample from the data set. So if we use one sample at a time, then this is the example of selecting a one sample. We see our data set has 12 samples. So if I take one sample, it has four features: A, B, C, and D. So this is the example of one sample, and this sample has all four features A, B, C, and D. When I have to train my neural network on this sample, I have to take the number of neurons in the input layer equal to the number of features present in the sample. So this is very important concept in going further. When we train a neural network, the number of neurons in the input layer must be equal to the number of feature in a sample. they are not equal to the number of sample. You can see we have 12 samples, but the common thing in all 12 sample is that every sample has 4 features. So this is the point to start with. So the number of neurons in the input layer of a neural network must be equal to the number of features present in a sample. So this is the example of training a neural network with one sample. So we can select this sample from anywhere. I can start training from the 9 sample, then 12 sample, then back to the 4 sample. Since I can select the sample randomly, therefore the gradient descent is called stochastic gradient descent. So the best way to train the gradient descent is to train through mini batch gradient. So if you train through a mini batch gradient, in that case, we can select any size of a batch. Here, the batch size is 4. So since we have discussed that one sample selection is not a good idea because the dataset are very versatile. So it's better to increase the batch size from 1 to 4, 8, 16, 32. Anything depends upon the number of total samples available in our dataset. Here is the example of gradient descent with batch size is equals to 4. You can see we have selected a batch size of 4 and we are passing 4 sample at a time. So this is the example of passing 4 sample at a time. Now you can see here all the 4 samples have equal number of feature, that is 4 feature, and we will again use 4 neurons in the input layer of a neural network. So this is the concept of a stochastic gradient descent. So stochastic gradient descent is the variant of gradient descent where we use a batch size of 4 or more in order to train. The advantage is first we pass this batch size which has a 4 sample and we get the output here, and from the output we again propagate back and update the weights. So every time we pass 4 sample, we update the weights, then we pass 4 sample and update the weights. So in this way we get better result when we train the machine on the batches rather than passing the whole epoch at once. So I hope you understood the basic theme or basic idea of a stochastic gradient descent. Thanks for listening this lecture, and I will see you in the next lecture.